Chinese researchers produce water, oxygen, and fuel from lunar soil in a breakthrough that could transform moon missions. In our latest video, we discussed how NASA has set its eyes on the moon, once again, with plans to send astronauts back to the lunar surface by 2024. But China is also planning some groundbreaking missions to the moon in the coming years, especially as it aims to become the first country to land humans on the far side of the moon. And now Chinese researchers have achieved something that could be a major boost for their future missions and transform our future on the moon. Chinese scientists have successfully extracted water, oxygen, and fuel from lunar soil simulants. The simulants were brought back to Earth from the moon during the Chang'e 5 lunar sample return mission in 2020, which was China's third lunar exploration mission. As part of this mission, China successfully landed a spacecraft on the moon, collected samples of lunar regolith or soil, and brought them back to Earth for study. Some of this lunar soil was provided to scientists at the Chinese University of Hong Kong for experiments. And what they found was very exciting. In laboratory tests, researchers found that lunar soil contains a high concentration of minerals that can be used to produce water, oxygen, and methane fuel. This discovery suggests that these resources could potentially be used to support human activity on the moon, such as sustaining life through oxygen production, or as rocket fuel to enable more missions. According to senior space scientist Li Chunlai from the university's Department of Earth System Science, the research shows that there are abundant resources on the moon that can be utilized to help humans establish a presence there. We previously knew that lunar soil could be used to make cement for building lunar structures. However, this study goes further by demonstrating that it can also be used to produce water, oxygen, and fuel for human use. The study, titled Resource Assessment of Lunar Regolith 4 In Situ Resource Utilization on the Moon, was recently published in the International Journal of Astrobiology. It describes how researchers used acids to treat the lunar soil in a process known as acid leaching. This process involves dissolving desired substances from the soil by reacting them with an acid, in this case, hydrochloric acid. The resulting solution contains valuable resources such as hydrogen, oxygen, aluminum, and iron. Using a device called a solar water vapor electrolyzer, researchers then separated the water from the other elements. This device splits water molecules into their constituent hydrogen and oxygen atoms using solar energy. The hydrogen and oxygen can then be collected separately or recombined to form water. In this experiment, the team produced 13.7 grams of water from just 40 grams of lunar soil. They also recovered 98% of the oxygen in the sample and produced about 30 cubic meters of methane fuel. These results are particularly promising because the lunar soil used in the study was not actually from the moon, but simulated using a mixture of various materials that mimic the composition of real lunar soil. Therefore, the researchers believe that if they can achieve these results using simulated soil, the actual amount of resources obtainable from real lunar soil could be even greater. The production of water and oxygen is particularly important for future moon missions. Currently, rockets carrying supplies to the ISS often include water as part of their cargo. This adds significant weight to the spacecraft, increasing launch costs. Producing water on the moon would eliminate the need to transport it from Earth, saving both fuel and money. Additionally, oxygen is crucial for sustaining human life on the moon, and current plans call for astronauts to extract it from lunar regolith. But why extract oxygen when it's more efficient simply to bring it along? Well, the answer lies in the thin atmosphere of the moon. The moon has a very thin atmosphere, almost 1 million times thinner than Earth's atmosphere. This means that there is very little air or oxygen available on the moon to support human life. Astronauts on the moon will need a constant supply of oxygen to breathe and to sustain themselves. While current plans are to bring oxygen from Earth, producing it on the moon using lunar resources would reduce the amount of cargo that needs to be launched, making missions more cost-effective. China has already invested heavily in researching ways to extract oxygen from the moon. In late 2020, it launched the Chang'e 5 T11 mission, an experimental satellite designed to demonstrate technologies needed to extract resources from the moon, including oxygen. The satellite was equipped with a device that can produce up to 650 liters of oxygen per hour, using lunar soil. The oxygen can then be used for a variety of purposes, including sustaining human life, fueling rocket engines, and supporting industrial processes. The potential applications of this technology go beyond just the moon. In fact, it could also be used on Mars or any other celestial body with a thin atmosphere where breathable air is scarce. For example, Mars has an atmosphere that is about 100 times thinner than Earth's, and is mostly composed of carbon dioxide. While this makes it difficult for humans to breathe, it does offer a potential source of oxygen. By extracting oxygen from the Martian atmosphere, future explorers could sustain themselves on the planet without having to carry oxygen from Earth. This could significantly reduce the cost and complexity of future Mars missions and open the door to more extensive exploration and even colonization of the red planet. However, it's worth noting that there are challenges associated with extracting resources on other planets like Mars. For example, the process may require specialized equipment and expertise. Additionally, there may be legal and ethical considerations regarding resource extraction on other celestial bodies. The Outer Space Treaty of 1967, which governs space exploration and resource extraction, prohibits national appropriation of celestial bodies and their resources. This means that no country or entity can claim ownership of any celestial body or its resources, including water, oxygen, or fuel extracted from lunar or Martian soil. While the concept of extracting resources from other planets holds immense potential, it's essential to ensure that it is done sustainably and responsibly. It's important to continue exploring and researching the viability and implications of extracting resources on other planets, while also considering the ethical, legal, and environmental aspects involved. As the world focuses on the potential benefits of resource extraction on other planets, it's also crucial to prioritize safety and environmental protection. Measures should be taken to prevent contamination of other celestial bodies with Earth's microorganisms and to minimize the impact of resource extraction activities on the environment. It is essential to strike a balance between the pursuit of knowledge and exploration and the responsibility to preserve the integrity and potential habitability of other worlds. The potential for resource extraction on other planets like the Moon and Mars is truly fascinating and offers exciting possibilities for advancing our exploration and understanding of the universe. However, it's important to approach this topic with a sense of responsibility and caution. By working together and taking proactive steps to ensure sustainable and ethical practices, we can harness the opportunities presented by resource extraction while safeguarding the wonders of the cosmos for future generations. The Chang'e 5 lunar soil that was used in the study is stored at the University State Key Laboratory of Earth Surface Processes and Resource Management. Professor Lee plans to use a larger amount of soil to conduct further experiments aimed at extracting rare earth elements, which are valuable for use in microelectronics and other high-tech applications. In addition to the resource extraction capabilities of lunar soil, Chinese researchers have also been investigating its potential for use in construction. Previous studies have shown that lunar soil can be used as a raw material for producing cement, which can then be used to build structures on the Moon. This could be particularly useful for future lunar bases or settlements where materials are scarce and need to be sourced from the Moon itself. Furthermore, lunar soil has also been found to contain other valuable minerals such as iron, titanium, and aluminum. These minerals could be extracted and used for a variety of purposes, including manufacturing tools and equipment or as inputs for other industrial processes. Such capabilities would be invaluable for future lunar missions and could help to make human exploration and habitation of the Moon more sustainable. The potential applications of lunar soil are vast, and researchers are continually finding new and innovative ways to utilize this unique material. As we continue to explore the Moon and push further into deep space, the ability to utilize lunar resources will become increasingly important. It could play a crucial role in enabling us to establish a permanent human presence beyond Earth and open up new frontiers for exploration and discovery. Overall, the discovery that lunar soil can be used to produce water, oxygen, and fuel is a significant breakthrough that could revolutionize our approach to future Moon missions. The ability to extract these vital resources from lunar soil could make it easier and more cost-effective to sustain human life on the Moon, enabling us to explore and utilize this unique environment in new ways. Thank you for watching. If you enjoyed the video, don't forget to hit the like button and subscribe for more updates on all things space exploration. Your support helps us continue to bring you the latest and greatest in space news and technology. So again, thanks for watching, and we'll see you next time.